Hello, my name is Boian Mitov, the president of Mitov Software, and in this session we'll demonstrate OpenWire Studio, a new graphical development environment from Mitov Software. What is OpenWire Studio? OpenWire Studio is a codeless graphical development environment for Windows designed for users without any programming experience. It is built on top of OpenWire. It includes all the Mitov software components for video, audio, digital signal processing, computer vision, artificial intelligence, communication, data visualization, and much more. It also includes a Arduino-compatible Arduino communication, which allows easy creation of Internet of Things solutions. Why use OpenWire Studio with RadStudio? First, it allows rapid prototyping and testing of concepts. It also allows non-developers with expertise in specific areas to create and test projects. Finally, it allows Delphi developers to utilize projects created by such experts in other areas. Let's take a look at the OpenWire Studio. When you start the environment, you'll see a design area in the center of the application. On the left side, you'll have a navigation window, and below it, Object Inspector. On the right side will be the available components for OpenWire Studio. We'll start by creating a simple video player application. We'll drop a video player and image display. We'll connect the two, select a file for the video player. We can see the file in the preview. The project is ready to run. There are two ways to run this application in OpenWire Studio. You can run the project with the Run button, in which case it will run without debugging, or you can run it in debug mode, in which case, by hovering the mouse over the connections, you can see the data that flows to those connections. When a component is selected, the OpenWire Studio will suggest the best components that can be dropped and connected to the selected component. The components are organized in categories and subcategories. When we hover the mouse over a component, a hint is rendered showing the way the component will appear when dropped. We'll drop a rotate component from the transforms category, and we'll connect the player through the new component. We'll also drop another image display, and we'll connect the rotate to the image display. If we run the application, we can see the processed video, and we can select a good angle of rotation. We can also edit the angle with design mode. In addition, OpenWire Studio allows us to return any modified property to its default value by clicking on this back arrow. Since we saw how we can work with video, let's also add an audio display. To do that, all I need to do is add a scope component and connect the audio to the scope component. If I run the application, I'll be able to see my audio channel. I can also see both channels by using audio to real. If I drop the connection over this button, the scope will automatically add all necessary channels and will connect them to the audio tutorial. Here are both channels being displayed in the scope. Next, we can add some video and audio analysis. For this, first I'll add a histogram for the video. Then I'll add a scope to display the histogram. And I will connect them together. Next, I will add a spectrum display for the audio. I'll add a spectrum component and a spectrum display connected to one of the channels. Since the histogram includes the alpha channel and that contains always the same values, I'll disconnect it and reduce the number of channels on the scope. If I run the application, I can see my audio spectrum as well as the video histogram. Next, we'll add some ppm meters for the audio. We'll display the ppm in some gauges. We can run the project again. You can see that everything is working properly, including the two gauges for the ppm. In debug mode, OpenWire Studio allows even dropping new components and connecting them to the running project. The project will continue to run without interruption. We will also set the video player to loop, so the video will not stop at the end. And we can keep adding components. Such as this swirl component or even more displays. Furthermore, OpenWire Studio has a visual undo-redo functionality, showing the state of the design at every level. So if I want to undo the design up to this point, I can just click here while the project is even still running, and the project will be recreated exactly at the point selected. The same applies for the redo functionality. As example, up to this point. Here is our project as it was at this point of the design. As we demonstrated up to this point, programming in OpenWire Studio is done through making connections between the OpenWire pins of the different components. All components have certain number of predefined input, output, or state pins. In addition, New pins can be added through visual live binding. As example, if we want to control the enable-disable property of the grayscale component, we can add visual live binding to it. This is done by clicking on this pin button at front of the property. There are different types of pins that we can use. We can add a source pin, sync pin, multi-sync pin, or state pin. Source pin is a pin that can deliver data and will send to other pins the value of the enabled property. The sync pin can be used to be controlled from one source or state pin and change the enabled property. Multi-sync pin is the same as sync pin, however, it can be controlled by multiple sources. It has to be used carefully as the effect of multiple sources controlling the pin can be sometimes confusing and undesirable. Usually, this type of sync pin is reserved for event-driven functionality. The state pin will allow multiple components to share their state, so when one of the state pins is changed, all the others will follow to the same state. So let's add a sync pin. Next, I will add a checkbox to control that pin. The checkbox has a state pin that I can connect to the enable pin. They will be connected with a state dispatcher. A state dispatcher will allow them to share the same state. It will be automatically added if state pins are connected, or if state pin is connected to any other pin. Let's run the application. You can see that by using the checkbox, we can enable and disable the grayscale component. In addition to many different types of properties, OpenWire Studio allows adding pins to events as well as methods. As example, we can add a clock multi-sync pin to the start event of the player as well as to the stop event of the player. Or we can add a clock source pin to don't stop event. This will allow us to start and stop the player, as example with buttons, and generate events when the player stops. If we run the application, we will be able to stop and start the video player with the buttons. Since we added a multi-sync pin, we can add more buttons controlling the start as example. They all will perform the same start command. Don't stop event can be connected to other sync pins to receive events. As example, a watchdog timer. Connected to LED. If we run the application, the LED will light for 1 second every time we stop the player, or if the player stops by itself. In addition to the capability demonstrated up to this point, OpenWire Studio includes support for animation timelines. Here is one of the animation timelines demos. In this demo, we have only one timeline, and if we select it, we can view and edit the timeline. The timeline consists of multiple channels. Each channel can be of different type, such as real, alpha color, Boolean, string, and many other types, including date and time. We can also have channels containing events that occur at specific times. We can have more than one timelines, each started and stopped individually. This timeline is set to loop, and it will control other components through the standard pins as well as pins added through visual line binding. Each channel can have different periods, and each period can be of different type, such as linear, cubic, value, and other types, depending on the type of the channel. If we run the application, you can see that the animation timeline controls the blending between the two videos, which also is represented with those two thermometers, as well as the position, size, color, and text of the animated items over the video through this draw component. And we can see the values changing as the animation is controlling them. Including the colors. Combining timelines with visual line bindings and the rest of the properties allows creation of very complex time-controlled projects. Now that you are already familiar with OpenWire Studio, let's see how we can integrate OpenWire Studio projects in our Delphi and C++ Builder applications. The OpenWire Studio support in Delphi and C++ Builder includes a component that allows directly loading OpenWire Studio projects inside your application. The hosting component allows connecting data through OpenWire directly to any of the Mitov software's component packages for further processing, visualization, storage, or broadcasting of the data. The component supports multiple channels of data containing video, audio, real, complex data, and more. By using generic filters, the data can also be processed inside code. Let's see how it all works. We'll start with a new project. We'll drop a random generator, then a scope component. We'll connect the random generator to the scope. Then we'll add a low-pass filter to perform some processing over the signal. We can see here the characteristics of the filter. We'll add one more channel to the scope by dragging this button, and we'll connect the low-pass filter. If we run our application, we'll see the filtered data. Now that I have a working digital signal processing solution, I may want to use that solution inside Delphi. To do that, I have to send the data to Delphi. For that purpose, there are external output filters. I will add such filter, and I will connect the processed data. I will also add another filter with our original data, so we can receive both channels inside RAD Studio. If I run the project in debug mode, I can see what data will be sent to RAD Studio. The original and the filtered data. Now we'll switch to RAD Studio and see how we can get the data. We'll start with Delphi VCL application. We'll drop OpenWire Studio host component and we'll select the test project we just created. The component will automatically discover the channels in the project and will add them. You can also manually add and configure channels. Next, we'll add a scope component to display the data that arrives. We'll add one more channel to the scope, and since we added the original data as a second channel, we'll connect it first on the scope and our process data on the second channel of the scope. We'll compile and run the application. You can see the data arriving from the OpenWire Studio project. This is the original data and the processed filtered data. If we want to work with the data inside our code, we can add a generic real component and connect it with the channel with the process data. If we double-click on the component, we'll generate event handler for its own process data, and we can work with the input and the output buffer of the data. If we work in C++ Builder, we can do exactly the same. Connect the scope and the OpenWire Studio host. Add generic real filter. Connect it to the original signal. And then work with the real buffer when the data arrives. OpenWire Studio also can host other OpenWire Studio projects the same way as Delphi and C++ Builder. We can do it exactly the same way. Here is our hosted OpenWire Studio project. And as you can see, it works exactly the same as in C++ Builder or Delphi. Now that you know how to use OpenWire Studio projects inside Delphi or C++ Builder, it is time to look at the big picture. In addition to RAD Studio, OpenWire Studio can be integrated with .NET applications such as C# or Visual Basic .NET, as well as Visual C++ applications. OpenWire Studio also can communicate with Arduino boards programmed with Visuino. Visuino is a new product from Mitov software. In essence, it is OpenWire Studio for programming Arduino-compatible boards. We will cover Visuino in more details in another session, so here we will do just a quick demonstration of how we can prepare it for communication with OpenWire Studio. There are multiple ways of communicating between OpenWire Studio and Arduino boards. The communication can be done over serial port or socket. The socket can be over Ethernet, Wi-Fi, or GSM GRTS. We're also working to add Bluetooth support. The simplest form of communication we can try is just to send some text data. For this, I will connect one of the analog inputs to the serial port, and I'll generate the Arduino sketch. Now I can compile and upload it. My board is programmed and ready to work. I can test the communication. In this case, I have a photoresistor connected to the analog pin, and I can see the data changing as I am covering it and uncovering it with my hand. Now let's switch to the OpenWire Studio and see how we can receive this data. I'll add a COM port component, set it to the right port where my board is connected, and add a terminal component. Then connect the two. If I run the application, I will see my data arriving in text form on the terminal component. This type of communication is very limited as it just provides us with text data without any structure, and it does not allow us to send more than one channels. For this, both Visuino and OpenWire Studio have a structured data communication. To send multiple channels in structured form, we'll use the packet component in Visuino. We'll add 2 analog channels and 2 binary channels. We'll set a unique head marker. I usually use 5555. This will ensure that we can discover the beginning of a package in the middle of communication. Then connect the output of the packet component to the serial port. Disconnect our old analog connection and connect the analog port to one of the channels of the packet component. For the second channel, we'll just use a signal generated by the software, in this case a sine wave. Then we'll connect the 2 other digital channels and generate the sketch. Upload to the board, and we can test our new communication. You can see that the data arrives from the board. Now let's go to OpenWire Studio. We'll replace the terminal with a packet component. We'll add 2 floating point channels and 2 binary channels. We'll set the header marker to match the one in Visuino and connect the component to the serial port. To watch the data, we can use the scope or the gauges from the instrument lab. Or both. And we can use some LED for the binary channels. Now we can test our communication. And you can see that the data is arriving, and we can monitor and control it. In this case, with my hand again covering and uncovering the photoresistor. Finally, we'll demonstrate how we can send data from Arduino to OpenWire Studio over sockets. As we mentioned, there are many ways to send data from Arduino, and there are many different types of Arduino boards. Some of them have built-in Ethernet connection, others have Wi-Fi, as well as GSM, GPRS connectivity. In this case, I will use Arduino Uno with an Ethernet shield stuck on top of it. To use the shield, I will add it to my Arduino board in the project. Next, I need to set the MAC address for my shield. For this, I can use MAC address generator or use one of the MAC addresses from some of the online tutorials. I will use this one. Next, we need IP address for our shield. I will use a static IP address so I can easily find it on my network. And I will enable the usage of that fixed address. To do the communication, I will add a server TCP socket. I will set a port for the socket, 8080. I will get the output from my packet component and connect it to the pin of the server socket. And I will disconnect it from the serial port, although I can send it to both of them. For my Ethernet shield, I also need to disable the DHCP to force it to use the static IP. Now I can generate and upload the sketch. In OpenWire Studio, I will add a client socket. I will set the port and the IP address, and I will connect its output to the unpacked component. Then I will delete the COM port and I will run the application. You can see that the data is arriving over the Ethernet the same way as it arrived over the serial port. This, in essence, is our first Internet of Things application created with Arduino and OpenWire Studio. This concludes our session on OpenWire Studio and its integration with Delphi and C++ Builder. Once again, my name is Boian Mitov, the president of Mitov Software. My email is mitov@mitov.com. Our website is mitov.com, and we offer the following products: VideoLab, a video processing library; AudioLab, audio processing library; SignalLab, digital signal processing library; VisionLab, computer vision library; PlotLab, data visualization library; InstrumentLab, visual instrumentation library; Intelligence Lab, artificial intelligence library; Logic Lab, Boolean logic library; Animation Lab, universal animation library; Communication Lab, serial and Ethernet communication library; Visual Live Binding, universal visual live binding library; OpenWire Studio, a graphical development environment for Windows; Arduino, a graphical development environment for Arduino. We also support some open source projects, including the OpenWire library, as well as the iGDI Plus, Delphi-friendly GDI Plus library. Thank you for listening, and now it's time for questions and answers.
Yeah, I mean, this is a brief overview of some of the new technologies we have been adding in the last year, and there is plenty of more stuff. It's very difficult to show all of the new stuff in just 30-something minutes. I try my best to show all the power, but we're working in essence to create a unified world of Internet of Things, Delphi, and graphical development environment with the power of video, audio, digital signal processing, computer vision, artificial intelligence, as well as all of the communication between all of those platforms into uniform and a very easy to use solution that anybody can quickly pick up and adopt.
There is a, let's see, there is a question about what about deployment licensing? Can you cover that, Boian?
Yeah, the libraries and everything else. The OpenWire Studio itself does require for the person using it to have a license. We will be looking at creating a runtime version which probably will be license free. At the moment OpenWire Studio still remains in beta and we're evaluating all of the different options. We're also working with other entities to license the OpenWire Studio technology for other forms of solutions. So each solution, sometimes covered by a different entity than us, will have probably its own license depending on how they want to distribute it. So any further questions or desire to discuss a specific licensing for the OpenWire Studio, I mean, please contact me. You have my contact information, and we can discuss it. The libraries themselves that communicate or host the OpenWire Studio projects, they are royalty free. So if you, as example, want to host OpenWire Studio project inside your Delphi application, you can obtain a license for the components, but any further deployment is royalty free. So that definitely is one option for executing OpenWire Studio projects without having to obtain multiple licenses.
Okay, and I put the URL for Mitov software in the chat window, so it should make it easy to click and get there as well. Let me see. Now, every time I see these products, and again, I know there's a lot to connect in. There's so many different sets of components, and now with Arduino and OpenWire Studio and the things that you can do with Arduino boards and so on, it's a really great solution that you're beta testing. Yeah, I was always wondering, what do I do with those Arduino boards that I had one, and then I got another one from my daughter, and it's fun to play with all the gears and lights and everything. And the work that you're doing to integrate Rad Studio into that solution is a great thing as well.
Thank you. I hope for even more great surprises in the near future.
Oh, that's great, Boian. Okay, Boian, thank you very much for joining us today at CodeBridge.
You're welcome. Thank you, David, for running a great show today.
Yeah, Ken is mentioning Arduino has an active Google Plus community. Can you talk about the Arduino Google Plus?
Yeah, I'm sorry I missed the last part of the question, but yeah, I can mention it. Yes, it's a big community with we're approaching 7,000 members already, and yes, it's a great community with a lot of people, a lot of resources, and a lot of really great momentum. It seems like there is a huge excitement about the Arduino. And if there are any listeners from the Arduino community, I have to thank you guys all for all the support you have been doing. I mean, this product relies a lot on feedback and communication with the users, and you have been fantastic. Thank you.
No, I remember when you started it with a very simple video demo and the first integration with the Arduino toolkit. And how far it has come. It's really amazing, and I'm just happy to be a part of it as well.
Thank you, David. That is correct. You were among the first two people, you and McKeith. You guys were the first two people literally to sit together with the people watching the Delphi week. So yes, Arduino was launched exactly at the Delphi week, and so it happened that we decided quickly between the three of us to do a quick demo, and so now it is recorded in history as the moment Arduino became available to the world.